Just a few years ago, it seemed that aviation was moving in an obvious direction. Aircraft would become larger in order to carry more passengers on a single flight. Large hubs, dense traffic, and growing demand made that logic easy to understand. But today the situation looks different. The largest passenger aircraft are gradually disappearing from routes, and this is not a random process. To understand why, we need to look not at the aircraft themselves, but at how the entire transport system has changed. To understand why larger aircraft stopped being the foundation of aviation, we need to look at how the industry worked in the past. For a long time, air travel was built around major hubs. Passengers from different cities flew into one large airport where a flow sufficient to fill large aircraft was formed. It was from there that long-haul flights were operated. In this model, aircraft size was an advantage because it made it possible to carry the maximum number of people on a single flight and reduce the cost per passenger. This system worked steadily as long as traffic remained concentrated. Large airports served as nodes through which a significant share of international travel passed. If an aircraft was filled, it became economically justified, even with high operating costs. That is why it seemed logical that the next stage of development would be even greater capacity and even larger aircraft. But over time, the conditions on which this model was based began to change. First, aircraft range increased. This made it possible to operate direct flights between cities that had previously been connected only through hubs. Second, more efficient engines and new design solutions appeared, making mid-size wide-body aircraft far more efficient. As a result, airlines gained the ability to operate differently. Instead of gathering passengers at one major airport, they began opening more direct routes. This changed the very structure of demand. Passenger flows stopped concentrating in one place and began spreading across different destinations. For large aircraft, this became a key problem. Their efficiency depends directly on high load factors. If an aircraft is designed for several hundred passengers but is not filled completely, the costs remain almost the same while profitability drops sharply. In the new model, where demand is distributed, achieving that level of load becomes much more difficult. In addition, large aircraft are tied to a limited number of routes. They are effective only where there is stable and high demand. These are usually major cities and the most popular international destinations. But there are not many such routes, and they cannot provide enough demand to justify a large fleet of aircraft like that. At the same time, smaller wide-body aircraft allow airlines to operate across a wider range of scenarios. They can fly between mid-sized cities, open new routes, and adapt to changes in demand. For an airline, this means lower risk. If demand falls, it is easier to adjust the schedule or switch aircraft types than to maintain the load factor of a large jet. Another important point is flight frequency. Passengers increasingly choose not only the destination, but also a convenient departure time. If the choice is between one large flight and several smaller ones throughout the day, many people prefer the second option. It offers more flexibility and better fits modern passenger behavior. As a result, a new logic began to take shape. Airlines started focusing not on maximizing aircraft size, but on matching demand more precisely and using the fleet more efficiently. Large aircraft remained part of the system, but they stopped being its foundation because the structure of air travel itself had changed. After route structures changed, the economics of each individual flight began to play a key role. Large aircraft have one specific feature. Their costs hardly change depending on the number of passengers on board. Fuel, maintenance, crew, all of this is required regardless of how full the aircraft is. That is why any underload immediately affects profitability. In a stable system, this was not a problem because passenger flows could easily be concentrated. But when demand began to spread across different routes, filling such aircraft became more difficult. And it was at that moment that large aircraft lost their main advantage. Smaller wide-body aircraft work differently. They allow airlines to match capacity more precisely to actual demand. That means that even with fewer passengers, a flight can still remain economically justified. Across the scale of the entire network, this gives airlines much greater control over costs. Another factor is flexibility in use. A mid-sized aircraft can be reassigned to another route more quickly if demand changes. It is not tied to a limited number of destinations and does not require ideal load factors to remain efficient. This allows airlines to respond faster to change without losing profitability. In the case of large aircraft, that flexibility is missing. If demand falls, there are few options. Either continue flying with low loads or reduce flight frequency, which also affects the overall efficiency of the network. Both options create additional risks. It is also worth considering infrastructure costs. Large aircraft require special gates, wider taxiways, and additional servicing resources. This limits the number of airports where they can be used without extra expense. In today's system, where routes are becoming more diverse, such limitations turn into a significant factor. As a result, airlines began making decisions based not on the maximum potential of an aircraft, but on real operating conditions. And under those conditions, the advantage gradually shifted to more versatile and economically predictable models that fit better into the new structure of air transport. When changes in routes and economics are combined with another factor, risk, it becomes clear why large aircraft lost their versatility. In modern aviation, it is important not only to operate flights efficiently, but also to be able to rebuild the network quickly. Demand can change seasonally because of events in specific regions, or even because of short-term factors. In such conditions, rigid solutions perform worse. Large aircraft are difficult to adapt to these changes. They are designed for stable routes with high load factors. If one of those elements disappears, efficiency falls. An airline cannot quickly move such an aircraft to another route without losing economic performance, because not every route can provide the required passenger volume. At the same time, more compact wide-body aircraft provide a different level of control. They can be used on different routes, flight frequency can be changed, and they can be adjusted to new conditions more quickly. This makes it possible to preserve stability even when part of the network operates differently than planned. Another aspect is connected to fleet planning. Airlines try to reduce dependence on individual scenarios. If the fleet consists of more versatile aircraft, risks are spread more evenly. In the case of large aircraft, any deviation from forecast demand has a greater impact because there are fewer alternative ways to use them. As a result, the choice becomes obvious. Even if a large aircraft can be effective under certain conditions, a more flexible solution looks more stable in the long term. That is why fleet structures are gradually changing, not because of one specific reason, but because of a combination of factors that make versatility more important than maximum capacity. In the end, these changes look logical when you look at the system as a whole. Large aircraft did not disappear because of one mistake or one failed idea. They were simply created for different conditions, where the main goal was to gather a large flow of passengers and transport them on a single flight. When those conditions began to change, their role automatically shrank. Today, aviation is built around a different approach. Demand is distributed across a larger number of routes, and the routes themselves have become more flexible. For airlines, it is important not only to fill aircraft, but also to be able to respond quickly to change while maintaining efficiency across different markets. In such a system, the advantage goes to aircraft that can work in different scenarios, not only under ideal conditions. That is why large aircraft remain only where their use is fully justified. These are the busiest routes with predictable demand, but there are not enough such markets to make them the foundation of the entire industry. As a result, aviation did not abandon large aircraft completely, but it changed their role. They stopped being a universal solution and became a specialized tool for specific tasks. And that explains why the sky looks different today than people once imagined, when size seemed like the main advantage.